This timestamp component is currently a simple presentational component. In fact, we don't need it to be a class component here at all. We can simply use a function component. One can argue, though, that this timestamp component should be a complete stateful one that manages its own state and tick the timer as well, in which case we don't need the global state. However, I'm going to assume that this timestamp is needed elsewhere in the application and leave it as part of the global state. But instead of having the timestamp component receive the value of the timestamp as a prob, maybe we can have the timestamp component itself read that value directly from the state. We are managing the state externally, so having child component read the state directly becomes an option. Please note that this is probably not the best option for this particular case, but the point here is to demonstrate that option. And in the next module, we'll take a quick look at the performance of this application. So we can simply provide the global context store to this timestamp component by using the store provider function. And to use that function, we just wrap the timestamp component with a store provider call. And remember that we need an extra props function. The extra props function actually is not optional, although we can easily make it optional here by checking for the value or provide the default argument. However, I'm just going to leave it required for now. So we're going to need an extra props, and I'm going to define this function here, and it takes in the store and the original props in case I need those, and it returns an object of props. So let's think about that. I don't want to pass the timestamp directly here. I want to read the timestamp from the state. However, instead of reading it directly from the state like that, we can make it into an extra prop in here. So call this timestamp and read it from store.getState function dot timestamp, right? We have that option. We have access to the store here in the extra props. So this should work as expected. We don't need access to original props because actually I'm going to kill the original props. So in the timestamp here, we're no longer passing an original prop to the timestamp component. We are just rendering it, and the timestamp component gets access to the store through the store provider, and then it maps an extra prop that is being read from the store state. And this will actually work. The timestamp is still ticking, and we can validate that. We have a timestamp container, and we have a timestamp that takes the timestamp value as a prop. Now, why exactly did this work? The timestamp component doesn't have a local state. It just gets property. Even the contained component doesn't have a local state. So this timestamp is actually working right now because since the global state is changing, the app component is rendering, and the app component is rendering all the children components, including the timestamp container and the timestamp. Although, if you think about it, the props and state of the timestamp container did not really change. So we might want to optimize our timestamp container, which is a valid case here. So I'm going to make it a pure component, which means if the props and state of the component didn't really change, then don't re-render. And if we do that, this timestamp is going to stop ticking. So the question is, why? Why did it stop ticking when I changed the timestamp container to a pure one, although the timestamp value on the global state is still changing? We are reading that value directly from the timestamp component through the store provider. We're actually getting the initial value. However, the timestamp component is not ticking. So pause the video here and think about that. Why? The timestamp is a presentational component. It just gets properties. So it doesn't have any state. And now the container component is a pure component. So it's not going to re-render unless it has a reason to, which means it has different props or it has different state. So although the global state is changing, this pure component doesn't really care about that. If we want to make the timestamp component a truly connected component, which means a component dependent on the global state, we basically have to fake a state change in the container component every time the store is changed. So we need to subscribe to the store. So we can actually do the exact same thing that we did in the app component. So I'm going to copy these lines and put them in the store provider in here. Paste the exact same code with a few differences. We don't need to start the clock here. We don't need to do set state in here. We'll talk about that in a little bit. We need to read the store from context instead of from props, because this is the higher order component that accesses the store directly from context. So we subscribe to the store, and every time the store is going to execute on store change. When the store changes, I don't really need to set the state here at all. I actually don't need to manage state on this component. All I need to do is give this component a signal that it needs to re-render, because the timestamp component is reading something from the store, which means I need to re-render this component to cause the timestamp component to re-render as well. So we can actually simply just use a force update call. So every time the state of the store changes, just force update this component, because we know that a contained component might read the state out of the store, and we need that contained component to re-render. So we can test that. And now the timestamp is kicking again because of that force update call. So the timestamp container is a pure component. However, it's being forced update every time the state of the store is changed. And this will cause the timestamp component to re-render. But let me say this one more time. This is probably not the best option for this particular case. However, we did that just to demonstrate the option that since the state is managed externally to the React application, children component can subscribe to that state as well. We don't have to pass the state from the app component. So if we have a component that is 5 or 6 levels deep, instead of passing the state through the tree, we can subscribe to it directly from the child component. And we can actually do that through the same store provider function. So now that we have a change state event every second, we want to analyze what's going on in the React application. What is the React application re-rendering? What is the React application taking to the DOM? And we'll do that in the next module.